All right, this is Dr. Odell Back to Health. I have Ted Shaun here, clinical nutritionist, standard process guru. And okay, Ted, today I want to see if we can talk about autoimmunity, protomorphogens in a Reader's Digest version that patients can comprehend, because I remember understanding and learning about this stuff, it was mind-blowing. But think we can water it down a little bit and patients can understand?
I think we can do that, yeah. I mean, that's probably the most biochemically diverse subject we could talk about, but yeah, I think we can do that just fine.
Awesome.
So, the big question most people have, and a lot of doctors have as well, is why does autoimmune disease take place? In other words, why does the body form antibodies against its own tissue and attack itself? Because that's what autoimmune disease is. And the drugs that are available for it are in a class called biologicals, and what these drugs do is they downregulate the certain aspects of the immune response that create antibodies specifically to our own tissue. And just that alone is very complex, so we're not going to dive into that, but that's what happens. And so the big question is, okay, as a for instance, when Dr. Royal Lee, who founded Standard Process, understood this process way back in the early 1930s, he postulated this idea that the body and this is before autoimmune disease was a thing. Mm-hmm. I don't even think the term was coined yet. So he said, I think what happens is the body creates antibodies to destroy its own tissue. And his contemporaries said, you're out of your mind. Why would the body do something like that? That's just stupid. But Lee understood the biochemistry of it much more so than any of his contemporaries did. And so this is what he postulated way back in the late 1930s, mid to late 1930s, and it took literally 50 years for us to understand, oh, he was right. So
again,
why does the body attack itself? Here's what happens. And this is not the only mechanism that causes autoimmune disease, but this is the primary mechanism of action, and it's not that hard to understand. So, when the body gets injured, and this can be injury through blunt trauma, it can be injury through chemical exposure, it can be injury through poor epigenetic expression because of environmental factors. In other words, there's things in your environment or in your food that have an influence on how your genes are expressed, and it causes the genes to express themselves in damaging ways, and then you have organ or tissue damage, and then an autoimmune disease. Well, why does this damage turn into an autoimmune disease? What happens is when tissue is damaged or an organ system is damaged on a cellular level, some of the cells are destroyed, and when those cell walls break open, the organelles and the nucleus and all the other things in the cells spill out into the pericellular fluid. And then, ideally, the lymph system, which is the body's garbage elimination system, picks that up, carries it to the liver, it's broken down, detoxified, and goes out in the urine and feces. If the injury is extensive enough, or more commonly, if the patient's nutritional status is such that the tissue can't readily repair, then you have subclinical or low-level long-term injury. And eventually what happens is, as those damaged cells release their contents into the pericellular fluid, the fluid outside the cell membrane, then those cellular components can be picked up by the capillary system, and then you have DNA from the nucleus of the cell,
material from
genetic material in the blood. That is a 4-star fire alarm for your body.
The body does not like genetic material floating around the blood, does it?
It does not. The blood is not a DNA transport system. Okay, it doesn't work that way. And what could happen is if the DNA or nucleoproteins from these damaged cells that are now in the bloodstream land somewhere else in the body and lodge there, then what can happen is they can actually start growing into that tissue or organ in a foreign area of the body they don't belong. You would not want a new liver growing in the back of your eye socket.
Exactly.
Okay? And people say, that's preposterous, that's never happened. Well, why hasn't it ever happened? Because When those antigenic proteins get into the bloodstream, the body says, hey, we don't want a liver growing in the eye socket. Go build antibodies to destroy those liver cells. We're using liver as an example, before they start growing. And so the control mechanism to keep that from happening is the body creates antibodies to destroy these liver-based proteins that are in the blood because the liver was damaged. Unfortunately, if their nutritional status is not adequate and liver specific enough for them to repair their liver, then what happens is that process, the liver continues to exude damaged cellular material, cellular nuclear proteins, DNA. Maybe at a slower rate, but it's still releasing them. And so what happens is those antibodies pick up those antigenic proteins, and like a shark sniffing out a blood trail in the ocean, they follow it right to the target that's releasing those antigenic proteins in the first place, which is the liver. So then those antibodies start attacking the liver itself. And then the liver has no hope of repairing because it's under constant antibody attack, which weakens its function, weakens its structure, weakens its ability to rebuild and heal.
And then when it gets to a point down the road where it's like, we call it a diagnosis, right? Like, I mean, this process goes on for a while before we actually have a clinical diagnosis of an autoimmune
Yeah, and so when you have a clinical diagnosis of an autoimmune disease, what they find is that there are antibodies to a specific tissue in the blood. So when someone has what's commonly called a heart attack, and the way they confirm that the patient actually had one is they do a blood test and they look for heart tissue antibodies in the blood. And if they see them, they go, yep, you have damaged heart tissue, you have heart DNA in the blood, and you have antibodies to that heart DNA trying to kill them off so you don't grow another heart. Mm-hmm. They don't play it that far out, but that's how they recognize someone actually had a heart attack. There's antibodies to the organ in the blood. And so that's the reason heart attack patients are told over and over again, well, you can't shovel snow anymore, you can't ride your bike anymore, you have to really be mellow and not upset your heart, not overexert yourself, because now your heart's weakened.
Now you got sharks in the water.
Yeah,
right?
You got little antibody sharks biting the heart all the time, so the heart remains in a weakened state unless you do something to downregulate the production of those specific antibodies. So you have to do two things. You have to provide the nutrients to help the organ system repair, or the tissue system repair, so that it can repair the damage and stop exuding nucleoproteins in the bloodstream. And the other thing you need to do is downregulate the antibody response to that tissue or organ. So then the question is, well, how do we do that? Oh, biological drugs. No, that's not how we do it. So years and years ago, early 1900s, there were a number of enterprising doctors who understood the Chinese medicine concept of like cures like. And so there was an instance of a young boy in the early 1900s that had parathyroid disease, and his doctor took parathyroid gland from a cow, diced it up on a plate, cooked it a little bit, and fed it to the kid, who had an almost immediate improvement in his parathyroid function, because these glandular products, when you take them, it's just like giving the target organ a special multi-nutrient vitamin mineral supplement that is specific to the functionality of that organ. In other words, if you want to really help the adrenals out, the best thing you could do is eat some bovine adrenal, because it has all the nutrients, cofactors, and synergists that the adrenals need for day-to-day function, because those organs sequester and store those nutrients for their function when dietary nutrition doesn't supply them. So, when we give someone a target glandular product for a specific ailing organ, and that glandular product matches the identity of the organ under stress, it helps the organ to rebuild. But protomorphogens are a little bit more specific. They are...
Yeah, because you've seen, you can get glandulars, anywhere, right?
Yeah, protomorphogens are slightly different than just glandulars. So generally glandulars are desiccated glands. Yeah. That's all they are. And they have some of these protomorphogens in them, but not in huge concentrated amounts. So back in the day, when someone had a heart attack, back in the day I always mean the 30s and 40s, when someone had a heart attack, I said, well, if you can start eating heart meat, your heart will do a lot better. And that was the extent of it. Now, with the protomorphogens, which are actually the nucleoproteins of the target tissue, when we take those orally, what happens is that changes the immune response. It kind of distracts it. Okay.
Yeah, I've heard it been described as signal flares, right? Or flares on a jet when they've got fighter jets and you've got the missile coming and then they hit the flares.
Yeah, they actually release a phosphorus compound which burns hotter than the jet fuel. So if it's a heat-seeking missile, it goes, oh, the phosphorus is hotter, I'm going to go after that. That must be coming from the jet engine, and they're called countermeasures, and it blows up the attacking jet behind them.
Yeah.
Protomorphogens work very similar. The immune system says, oh, wow, I've got all these antigenic proteins in the digestive system. I'm going to pull the attack off the liver, and I'm going to concentrate on getting rid of these antigenic proteins that the patient just took. So someone might ask, well, if the problem is I have too many antigenic proteins from my liver and my bloodstream anyway, and I take the liver PMG and I'm putting more in through my digestive system, isn't that going to make the problem worse? No, because what happens is the body reprioritizes and it increases phagocytosis. Those are the immune cells. They're like Pac-Man that go around and gobble up things that shouldn't be there. That changes phagocytosis so that the phagocytes go after these antigenic proteins and the antibodies that are built to destroy them. And so what happens is as you feed the liver with, say, something like Livoplex, it's kind of like everything but the kitchen sink for liver health. Mm-hmm. You take the Livoplex, but you also supply the hepatrophin PMG. That downregulates the immune attack against the liver, and while you feed the liver can now, because it's nutritionally equipped to heal itself, that process can begin, and then
so it's not leaking that stuff back in the system.
Exactly.
And then I've seen amazing results. I mean, I've been using this for years, these protocols with the protomorphogens, and so also I use echinacea in Romania. How do those work?
Those are really important because this whole autoimmune process is kind of a branch of the inflammatory process, but it's very specific. In other words, in the autoimmune process, you have immune cells called T cells, and you have lots of different types of T cells, but for the sake of simplicity, you have two primary types: T helper cells and T regulatory cells. T helper cells are like Marines. They just go in and kill everybody. It's like, everyone's an enemy, let's kill them all. Let God sort it out.
Hoorah.
Exactly. And the T regulatory cells control that activity so it doesn't get out of hand. So when someone has an autoimmune condition, they have a lot of accelerated T17 activity. T17s are the cells that are instrumental in creating antibodies to attack our own tissue. So when you take echinacea and Rehmannia, or I should say Rehmannia complex, that's a little bit better than straight Rehmannia. What these do is they downregulate the differentiation of T cells from T helper cells to T regulatory cells. In other words, less T helper cells, less Marines killing everybody, and more of the regulatory cells that control the Marines' aggression. So you have to have a lot of T regulatory cells to keep the activity of T helper cells in check, and that's what echinacea and Rehmannia complex do. Is they change that ratio of T helper cells to T regulatory cells so that it's T regulatory cell dominant, and then you reduce the damage and inflammation that's caused by this autoimmune reaction.
Everybody just calm down now.
Exactly. That's exactly what's going on.
Amazing as a base protocol, and obviously you can get a lot more in depth, but the thyroid, I mean, how common is that, with people with thyroid problems right now, right?
Yeah, the thyrotrophin PMG, which is the thyroid nucleoproteins, are our most popular PMG product because there are more people with Hashimoto's, hypothyroiditis. Yeah. I mean, they're everywhere.
I've been amazed throughout the years. I've been using this protocol for a long time, but it's almost like just one of those things like, no problem, we'll take care of that. And then you look at the alternate route for these patients, what they go through, and it's like, oh my heck. I mean, seriously.
I know you wanted to say something far more volatile.
Yeah, it just blows my mind, like we're going to put you on chemotherapy drugs and just craziness.
Well, what they're trying to do, and I understand their intention, they're trying to suppress immune function. But if you suppress, and they can't pinpoint it to the extent where they go, well, you know what, we're just going to downregulate T17 helper cell activity and we're going to leave everything else alone. The drugs aren't that specific.
Yeah.
So what happens is you have depressed immune function, and you downregulated the autoimmune attack on the target organ, but now the patient's more susceptible to colds, flus, viruses, bacteria, everything else, because the whole immune system has been taken down a bunch of notches, and their defensive systems aren't there to fight off regular everyday stuff that's far less or far more innocuous than an autoimmune disease.
Yeah. Well, cool. I think we did a pretty good job of keeping it under control.
Wasn't too complex. Wasn't too complex.